Okay, let's move on now to section 10.7.2, where we talk about the root test. Okay, so the idea of the root test is again that we're going to compare to the geometric series, but here we're going to be given a series sum n equals 0 to infinity of an, and then what we're going to calculate is the limit of the nth root of the nth term. So I've written that in two different ways that mean exactly the same thing, right? The nth root here is the same thing as raising it to the 1 over nth power. This second formulation is the one I'm going to recommend us work with because this is going to be a lot easier to manipulate than these nth roots. Okay, and just as in with the ratio test, there are going to be three possibilities. This series can converge, and that's going to happen if this r is going to be less than 1. The test can be inconclusive if we get r equals 1, and then the series can diverge if this r is bigger than 1. So let's do an example. Let's consider the series n equals 1 to infinity, where we take n over 2n plus 1 and raise it to the power n. So let's calculate this quantity r here. This quantity r is going to be the limit as n goes to infinity, and we're going to take this whole expression, I'm going to put a square bracket out here, and we're going to take it to the 1 over nth power, and then I'm going to stick this thing inside. And conveniently now we see that this nth power and this 1 over nth, this nth root, they're going to cancel each other. So this is going to give us the limit as n goes to infinity of n over 2n plus 1. And now as we take this limit, we're going to get, right, the numerator looks like n, the denominator is 2n plus 1, so we're going to get a limit of 1/2. 1/2 is less than 1, so this series converges. So this series converges by the root test.